Welcome. This is Mr. Sutton bringing you the IM3 Honors 4-2 Extra Practice number 3 solutions on completing the square. For this problem, to solve for x, we notice that we already have a perfect square on one side of this equation. So we can actually just go ahead and square root both sides right away. That's going to leave me with x minus 5 on the left and plus or minus 7, the square root of 49, on the right side. At this point, all that remains is to get x by itself by adding 5 to the other side. So I can write the other side as 5 plus or minus 7. And since I can combine 5 and 7, I should go ahead and do so. 5 plus 7 gives me 12, and 5 minus 7 gives me my other solution of negative 2. On this problem, trying to solve for x, one option on this one would be to subtract 81 from both sides and try to factor the left side. But if you take a look at the left side, this is actually already a perfect square trinomial. We have basically a squared, this is 2ab, this is a b squared situation. Half of 14 squared is 49. So we can actually factor this left side here into x plus 7, the whole thing squared. And at this point, since we have a perfect square on one side, we can go ahead and square root both sides to solve by square rooting. So that leaves me with x plus 7 on the left side. And on the right side, I have the square root of 81, which is 9, but we have a plus or minus over there. So x plus 7 equals plus or minus 9. Now I'm just going to subtract 7 to actually get x by itself. So that's negative 7 plus or minus 9. And I can combine negative 7 and 9, so let's do so. Negative 7 plus 9 gives me a solution of 2. And then negative 7 minus 9 is my other solution of negative 16. For this first problem, where we're trying to solve for x, we notice that we already have something squared on the left side. So to get to x, why don't we just square root both sides? And if we do that, we're going to have to use a plus or minus over on the right side. So we'll have x minus 3 equals plus or minus 6. And then to solve for x, we just add 3 over here. So 3 plus or minus 6. Since we can combine 3 and 6, we have to write two different answers here. So we've got 3 plus 6, which is 9, and 3 minus 6, which is negative 3. For this problem, we have some options. Option number 1, which doesn't end up working out very well, is if you move the 8 over here, you could try factoring it, but it can't be factored. Next option would be to subtract the 9 over to the other side and then complete the square, except that if you look closely, you've actually already got a perfect square trinomial over on the left side. This can be factored into x minus 3 quantity squared if you just square root the first and the last thing. And just double checking, if I multiply these together and double it, I do get negative 6x. So continuing here, now that we've got something squared, we can square root both sides. So that'll be x minus 3 equals plus or minus square root of 8. And they want it in simplest radical form, so 8 I can split up into 4 and 2. Square root of 4 is 2. And then while I'm at it, why don't I just add this 3 over here to get x by itself. So when the dust settles, we'll have x equals 3 plus or minus 2 radical 2. For number 7, if 4p plus 1 quantity squared equals 81 and p is greater than 0, what's a possible value of p? So let's solve for p, and then we'll worry about what this p greater than 0 business means a little bit later. First step on this, since I already have a perfect square on the left, I'm going to square root both sides. That'll give me 4p plus 1 equals plus or minus 9. Then let's see here, a few more steps. I need to subtract 1 and then divide by 4. So we'll have negative 1 plus or minus 9 all over 4. Since I can combine these, I'm going to, so that I can actually get a complete answer here. So I've got negative 1 minus 9 over 4, so negative 10 over 4, which is negative 2.5, or negative 5 halves. And then we have negative 1 plus 9 over 4, that's 8 over 4, which is 2. That's two different answers, but now we have to reread the fine print here. They said p is greater than 0.
So that means this negative 2.5 answer is no good. We're just going to stick with this answer of 2 so that we satisfy p greater than 0.